So we'll continue with the first lecture. Am I audible? So in the previous class, we were discussing about just introduction and overview of the microprocessor course. And Sir has explained, so why we are studying, I mean, what is the scope of the subject? Suppose if you are moving to the architecture side, so what are the job requirements? Okay, so before studying here, you should also know, you will think why we need this architecture and on where the architecture is used, what are the different companies which are using the architecture. Okay, so just I'll put the video from yesterday's, whichever it's continuous here for 2 minutes, then I'll move to the second class where we are discussing introduction to the ARM processor. As yes, excuse me. Just we'll go through the what are the job requirements with the microprocessor. Hello students, I hope it is clear for the job description and what are the companies we have regarding this microprocessor. So now I'll move to the slide. So instead of playing the video, just I will go to the slide itself. A video you can download it from the PESU Academy. So we are going to start the first unit here. The first unit is the microprocessor and computer architecture. So in that we are discussing about introduction to microprocessor. So in the previous class, just we are discussing the introduction to the subject and the requirement of the subject and as well as the job oriented. Uh, so are you seeing the PPTs?
Ma'am, it's not visible.
PPT is not visible.
No, ma'am.
Now is it okay now? See the previous video also it was not visible, isn't it?
Yes,
No.
ma'am.
Yes.
No, ma'am, the video wasn't visible at all.
You could have tell me no. Always I used to ask before, am I audible? Or it won't look like, so we use not to ask, am I audible? Or if anything, you should tell before itself. Okay. Okay, now I'll move to the slide. But were you able to hear the noise actually in the previous? Hello? Were you able to hear the noise?
No, ma'am.
Job oriented things?
No,
No,
ma'am.
ma'am.
Okay, I'll put once again at the last after completing this. So this will be the first slide we are discussing about introduction to microprocessor. So the subject is the microprocessor and the computer architecture. We'll see how we can define the computer architecture. So the task of the computer designer faces is a complex one, isn't it? So determine what attributes are important for a new computer, then design a computer to maximize performance and energy efficiency while staying within the cost. Okay, so even if you are buying a computer, a laptop will see the maximum performance and energy efficiency and the capacity memory within our cost, within the cost, power as well as availability constraint. So now here in this case, this task has many aspects including the instruction set design which we are going to study here, functional organization, logic design and the implementation. The implementation may here encompass integrated circuit design, packaging, power and cooling. So the optimizing the design requires familiarity with a very wide range of technologies from compilers and operating systems to logic design as well as packaging. So anyway, here in this case we were discussing about the logic design as in the previous class, digital design and computer organization. And again in the semester you are going to study about the operating system. See this, all these are interrelated subjects. So the term computer architecture referred in the previous years, some years ago, the computer architecture referred only to instruction set design. So other aspects of computer design were called implementation of an implementation is uninteresting or loss of challenging. So here under this computer architecture as computer microprocessor and computer organization. So first we'll discuss about what is a microprocessor. So introduction to the microprocessor. So right now we are here out of 5 minutes. We are in the first unit, basic processor architecture and design. Okay. In the first unit, so we need to study about what is a microprocessor, why to study the microprocessor, evaluation of the microprocessor, what are the different microprocessor we have, and is it microprocessor and microcontrollers are equal, the classification of processor, I mean CISC versus RISC. So what is the difference, what are CISC and RISC machines, what is the difference between CISC and RISC machines. From the unit 2 it continues. Okay. So the classification is based on some criteria. So now we need to understand what is the microprocessor. Okay. Where is a microprocessor in the system? So now this is the time to understand what is a microprocessor. Microprocessor is an electronic component which is used by the computer, okay, and which is having a and the microprocessor is a central processing unit which is made up of single chip implementation. Okay, so the single chip implementation of CPU, and it is made of integrated circuit which is having millions of small components such as transistors. And the microprocessor can be considered as a brain. Okay, I mean this is the central unit of the computer, and also it is a multi-purpose programmable devices. CPU performs lot of arithmetic and logic operations. Those generally the addition, subtraction, multiplication, comparisons, divisions, etc. and also moving of data from one location to another location. Oftenly these are called the processors, I mean CPU or logical chip. And the microprocessor can be considered as multi-purpose programmable devices, can be instructed to devise the task with having own capability, and these are designed to understand different binary instructions and to execute them. And after this CPU is essentially a microprocessor. We know that CPU is a microprocessor. All the CPUs in the devices are microprocessor, but not all the microprocessor are CPU. So I mean here, other than CPUs, we have some specialized microprocessor as GPU, NPU, TPU. I mean GPU is a graphical processing unit, NPU is neural processing unit, and TPU is tensor processing unit. These are all the specialized microprocessor. So what is a task of this microprocessor? See, these microprocessor are used for some special purposes. So if CPU is a common, actually it will be there in all the computers. Apart from this, we have GPU is, these are all the processors which are dedicated for image processing applications and which are very much required in nowadays for satellite image processing, Google mapping, and we need GPUs for processing graphics very fast. Next, TPU is a tensor processing unit. It is by the Google, and again it is a graphical processor. And these are all manufactured by TPUs. Next, middle one is a NPU. So NPU is nothing but neural processing unit. So processing unit. And these are all the lighter processor than your CPU. And these used for processing artificial intelligence based applications. So there are nothing to do with the graphical processing in the NPU. So graphical processing is removed from the NPU and it is made light. Okay, so lighter than CPU. So which is a NPU. And they can execute the processor. If you have the lighter the processor, the faster can be there based on the processor. So these are all the part of the microprocessor. So totally we have CPU, GPU, NPU, TPU, and all these can be considered as a processor or can be microprocessor. So next we need to see the clear, is multi-core processor a microprocessor? Yes, multi-core processor also a microprocessor. So we'll have more than one core on a single chip. We have many of the microprocessor. So we'll see one by one what are the different microprocessor we have. Intel 400 was the first microprocessor which is introduced commercially, which begins the microprocessor, is the Intel 4004 processors. So in this slide you can see the chip. So here microprocessor. Where is the microprocessor? So this is overall the part of the CPU we have. So now where we'll be having a microprocessor here. So first we need to realize where exactly the microprocessor presents. Okay. So motherboard. Okay. So you will be knowing this. Okay. The microprocessor is below the fan or the heatsink. So you can find if you open the computer, if you in the motherboard, if you open the fan, so it has seen that microprocessor. So in this now just we discussed the microprocessor or the processor will be below the fan. So why the processor will be below the fan? So here whenever it is executing, it dissipating the lot of heat. To cool that, the fan is mounted on the processor. So now you can see the view on the microprocessor, how the evolution of the microprocessor took place. So as we discussed here, Intel 4004 was the first microprocessor. So now here from here we need to start which starts from November 15th, 1971. So from there the microprocessor started here, the evolution of the microprocessor started. So after that you could see the figure here. We have 8008 in the April 1972, again 8080 in the April 1974. And again 4004, all these were introduced by Intel. And you can see lot of series for the years here: 8008, 80, 8085, 8086 and 8088. See, till now the academic peoples also used 8585. What is a microprocessor? So we used to have a programs. We used to execute the programs based on this 8085 microprocessor and 8086 microprocessor, which are invented in 1976 as well as 78. See, whenever we grow the here, the processor becomes stronger and stronger. Lot of transistors put inside the processor, and as the number of size transistor reduced, because if the transistors more, the cost will be high. So we need to see how we can reduce that cost also in the microprocessor. So as year goes and the evolution of the microprocessor also increases, and also it took part of how we can reduce the transistors also, number of transistors in that particular processor. So for every 2 years, number of the transistor inside the processor doubles. Okay. And Intel introduced the Pentium process in mid-90s, which become very popular among the desktops and the systems which are used commercially in the academics as well as in the industries. So you can start from here. The Intel Pentium start from 93 to 19. Next we have Intel Pentium Pro, Pentium 2, 3, 4, etc. And these Pentium 4 in the early 2000, they are very powerful and they were used extensively in different users, and this Pentium 4 machines was very popular. In the mid 2000, the popularity of the Pentium 4 were reduced, and this introduced Pentium. They introduced the dual core processor. So you could see here in the early 2000 to 2008. So, okay, so we're having the Pentium. Those were very popular, but they were having single core machines. So again, at the 2006 to 9, they were again Intel introduced Pentium dual core. So from there, dual cores, and next we have core quad, 4 core. They were started. And also the multi-core processor did not come in existed at that time, that dual core. And this multi-core, they were introduced uh, because they were not managed to power. So we need to understand this process in the last unit. So in the last unit, we are discussing the multi-core architecture. What is the relation between the power actually and the performance of the processor, because Intel, and we need to see the power also with the multi-core architecture. So that we'll discuss in the last unit. And number of cores on the chip became double here. We have quad core, 8 core, 16 core, so it continues. And nowadays you will get 8 core also, 16 core process core in the desktop application as well as in your mobile phone also. Along with Intel, there are other manufacturers like AMD, Spark, which were parallelly manufacturing the processors which are competing the Intel, and the Intel occupying the market, and it is more popular. So now we have including Intel processor, we have AMD processor. Okay. So now as a computer engineer, we need to understand all this here. And you could see here after the Intel Pentium, we have an Intel Atom processor also. So that's in between 2008-9. They were manufactured for tablet type of the devices, and these tablets are which were smaller in size, less power, and also they were able to execute arithmetic operations as well as some of the functions where the Pentium processor was doing. So this overall gives the evolution of the microprocessor. Okay. So you would have seen here it starts from 1971 to 2017, and it continues, which is the extreme edition of Intel Core i7 and i9. Now you would have seen that when you are buying a laptops, you would have seen that the i3 version, i5, i7 Gen, etc. So, which of now would have think which of the microprocessor we are going to study in our course? Okay, so definitely here, if I say which of the processor we are using, for example, I'll go to the extreme edition as Intel Core i9. Okay, but as a part of the study, we will consider a small processor, because nowadays what we are using the machines, okay, the Intel Core i9 or i7 machines, those are very will be having very vast of instruction set addressing mode, which is very difficult to understand here. So now we are going to study the microprocessor as a microprocessor, ARM microprocessor, and also the particular programs also you are going to execute in the lab. So we'll study the microprocessor with the basic things, and also how to write the programs, what are the instruction set, etc. with the ARM microprocessor. So these two slides gives the different microprocessor and the evolution of the microprocessor. And you can see also one more processor as Intel Xeon processor also, which is present, and Intel Celeron Xeon. These are powerful processors, and these are used for server building workstation or servers for data centers. So it was the evolution of the processor. So now we need to answer to motivate ourselves why to study the microprocessor. Obviously, we need to study the microprocessor. So obviously, the microprocessor will be present many of the things actually, and daily days we are seeing all those things. So as in the case example, almost all applications uses the microprocessor, microcontrollers, maybe your dishwasher, coffee maker, robots, TVs, any embedded application, if you take the small devices, will be having a microprocessor. So the device including your car braking system. So we need to know about the microprocessor. I mean, as a computer engineer, we need to understand the why we have to study the microprocessor, and also we need to study the programming part of the microprocessor. So now So we have a time to classify the microprocessor. What are the different classification of the microprocessor? Okay, so under the classification of the microprocessor, so we have a CISC microprocessor, or simply we'll call it as CISC machines. Okay, CISC machine means those machines or computers having CISC microprocessor. Example is Intel Pentium 4 is a CISC architecture. CISC machines are CISC architecture. And next we have a RISC, RISC, so ARM processor. Okay, so other example is a RISC, not example, other classification is RISC machine. So the best example for the RISC machine is ARM processor, which we are going to study in our subject. One more, the next one is special purpose. Special purpose microprocessor, like we have what we discussed, GPUs, NPUs and TPUs. So these are all the main classification of the microprocessor: CISC, RISC and special purpose microprocessor. So definitely we'll continue this, what is a RISC machine, what is a CISC machine, or what are the CISC RISC architectures and the difference between these two with some example also. So now we need to see the understand about RISC and CISC, which is very important to understand other concepts. Why we are moving to the CISC machines and why we are moving to the RISC machine. The abbreviation of the CISC is complex instruction set computer and the RISC is reduced instruction set computer. See, the name itself does that. CISC is a complex machine and RISC is a smaller one, I mean reduced instruction. So we don't have much instruction sets, addressing modes. So that's why we have taken in our study as a RISC machines, which is easy to understand how the microprocessor, how the program is executing. So the CISC stands complex instruction set computer, RISC stands for reduced instruction set computer. So next we'll discuss what is CISC and RISC. What is the difference between CISC and RISC? So we'll discuss in the coming slides. On what basis the microprocessors are classified? So these are all the three classifications. Okay. So right now we'll leave the special purposes. We'll discuss with CISC and RISC machines. Okay. So how to classify the microprocessor? So we have a basic characteristic which are differentiate the microprocessor, like instruction set, bandwidth and the clock speed. So there are three characteristics where we can differentiate. Three criteria are instruction set, bandwidth, clock speed. So what is the instruction set here? Instruction set will be having set of instruction which are used to communicate with other devices. I mean the instruction that the microprocessor can execute. Okay. So when you are writing the program in the high level language, it should convert it to the set of instructions. So all the high level language should convert to the machine level language. So machine level language will be having with the instruction set. Okay. So with this instruction set, again it is going to convert to the machine level, the pure machine level language, which is having only the 0 and 1. So the second criteria is the bandwidth, the number of bits processed in a single instruction. I mean size of the instruction as well as the clock speed. So the clock speed is how many instructions per second the processor can execute. So that we will discuss with the megahertz. I mean, it is given in the megahertz. So the unit is a megahertz. We will use for the clock rate. So in this section, we'll understand the instruction set architecture. So ISA. So what is ISA? The term instruction architecture, which is used to refer the actual programmer visible instruction set. So the ISA, so instruction set architecture serves as the boundary between the software and hardware. So the complete collection of the instruction that are understood by a CPU is the ISA, instruction set architecture. So the example of some of the instructions, okay, instruction set. So in that some data movement operation instructions, data processing instruction, branch instructions. So you have study on these instructions, but here with respect to the ARM processor, we need to discuss the instructions. So these are all the set of the instruction which are specific to the processor and we can execute our programs. The designers decide what type of instruction for the respective microprocessor, and it is the responsibility of the compiler to generate the correct and optimized code for the respective microprocessor. So if you take one microprocessor, will having particular set of the instructions only designed for that microprocessor. So if we are discussing different microprocessor, instruction set may be different. We can understand, but the how it is expressing some of the instructions can be different here. That we'll see with the example what are the different and what is the difference. Different set of instructions we are using in CISC as well as RISC. Okay, so the designer should decide the ISA, I mean instruction set architecture for the respective microprocessor. So the main criteria to classify the CISC and RISC processors. So as in the second port, the compiler has to generate the correct code, assembly code or the machine code for the from the high level language. So we'll take the example for the RISC versus CISC. So what is reduced instruction and what is complex instruction? Okay, so nowadays we are using a complex instruction set which can be fast here. Okay, so now consider the program fragments. I'll take one example here, and obviously this is from the high level language. A equal to B into C. I mean B and C is multiplied and the result will be stored in A. So there are three variables here. Before executing, we are giving the values B equal to 10 and C equal to 5 here. To execute the program, so what we have to do here? See here, either it can be add or multiply. Okay, so first what are the steps here? First we need to load B from the memory, C from the memory, then add B and C, then add or in this case multiply, store the result A back in the memory, so that the address of the memory is A here. So now suppose if I take the CISC computers, so what will happen here? How this instruction is executed? Okay, so before executing this, we'll understand the philosophy of the CISC processor. CISC processors were evolved in the 1970s and memory was small and expensive. the philosophy of the CISC processor is to simplify the code and make it shorter in order to reduce the memory requirement. So they try to accommodate almost all instruction in a single instruction instead of writing 3 steps. So it is checking how it can reduce to single instruction. Okay. So in CISC processor, a single instruction has several low-level operation. This makes the CISC instruction short, but it is a complex. But single instruction will be having many instructions here. So we are reducing to the single instruction. That's why it becomes complex instruction. So I'll take the same example here. Okay. So consider the programming fragments here, A equal to B into C, which just I have taken for the example. So how this will be there in the CISC machine? So I have a program 1, I have a program 2. Okay, in the program 1, mul bx, ax. I have one instruction. In the program 2, I have two instructions, move ax, 10, bx5, mul bx, ax. So in the first one, I am assuming Bx is in B. So now in this mul instruction, in the program 1, mul instruction will 5 and 10 from the memory, multiply 5. So now here in the program 1, 4 operations are embedded in a single instruction. So the number of lines will get reduced, but the complexity is increases. Otherwise, we have a second option here, I mean the program 2, loading A and B. For that I have a move instruction and I have a mul instruction. So again this mul instruction multiply 5 and 10 and store it in the memory location. So now if I comparing these two, so the memory required is only one memory for the program. Now if I go to the RISC machine, so what is the philosophy here? Idea of the RISC processor was originated in 74 and implemented in 80s. So the philosophy of the RISC processor is to simplify operation of the individual instruction. I mean, we will be having separate instruction for load instruction and store instruction. These load and store are the data movement instruction. And the number of lines of the code in the program is increases, but amount of the work done by the individual instruction is reduced. Okay, because each instruction is having one operation, so the work will be reduced here. So I'll consider the same example for the reduced instruction set computer. So you can see here the number of the lines are increases, but complexity of the instruction is reduced. Okay. So see the example. Move ax, 0. Move bx, 10. I mean 10 and 5 is moved to the B and C. Then add and okay, we are using some loop also begin. Add ax, bx loop. And again we are going back to the loop. So in the loop, I'll add B to A. So for this, you can consider it is A equal to B plus C. So how many lines I have here? Here I have we have 5 instructions here. For this, in the 6 machines, we'll be having only one instruction. So now here consider the program formats. So you can see the computations here. So consider the program formats of fragments work with the CISC and RISC machine. The total clock cycles for the CISC version might be the instruction RISC machine. Say 2 moves instruction into 1 cycle I'll take plus 1 mul instruction. If I take for the mul instruction 30 cycles, it is equal to 32 cycles. While the clock cycles for the RISC version is, and in the RISC version you can see we have 3 move instruction which is with 1 cycle, and we have 5 add. See here, instead of direct mul instruction we are using add instruction. You can work out this how it is happening instead of mul instruction with using add instructions. So 5 adds equal to 5. Suppose if I consider 5 additions into 1 cycle and 5, there are 5 loops into 1 cycle which is equal to 13 cycles. So with the RISC clock cycles being shorter, RISC gives much faster execution.
MOV instruction do?
Yes.
Ma'am, what does MOV instruction do?
MOV.
Yes.
MOV is move instruction, data movement. See, AX is, assume it is a register or it is a addressing location. Okay. Move AX comma 10, we are moving 10 to A. Say before, that means we are assigning the values. In the high level language, you will write no A equal to 10, B equal to 5. Okay, otherwise input data later you will give. Okay, so when you are giving the inputs and before adding or multiplying or any other operations, we should have an operand value. So here A and B are just operands, isn't it? So data movement operation, just we are moving the values to A and B, then we are multiplying Bx mul Ax comma Bx. Okay, so it multiplying and the result will be stored back in Bx itself. So with this clock cycles, RISC gives us much faster execution speeds because here we are not using any of the complex instructions like mul instructions. Okay, so next we have, okay, just I'll complete this. RISC versus CISC machine. RISC is a simple instructions, few in number. CISC is a many complex instruction. RISC fixed length instruction. I mean if it is only 3 instruction or it is a 4 byte only. But in the CISC machines, no, in single machine will be having either it is 1 byte instruction, 2 byte instruction. Under RISC, multiple register sets. In the CISC, we have a single register set. RISC, 3 operands per instruction. CISC, 1 or 2 register operands per instruction. So in the RISC, parameter passing through register windows, single cycle instruction, hardwired control, highly pipelined, only load and store instruction access the memory. So this is very important. To access the memory, we should use only load and store instruction. But in the CISC machines, we don't require directly. It can, many instruction can access the memory. The many instruction can access the memory. And in the RISC, we'll be having few addressing modes. In the CISC, we'll be having many addressing modes. Okay. So again, this part will discuss what is a highly pipelined. I need to discuss some more here. Okay. Now, anyway, I think it is time up. Okay. So we'll discuss these 2 slides, and also I want to discuss about the job oriented, which you missed at the time of the starting part, that will continue in the next class. Okay, so students, any doubts here?
Ma'am, I had a doubt.
Yes.
Ma'am, can you go to the previous slide once? Yeah, here, how do we know that we are looping 5 times, ma'am?
See, move AX, initially AX equal to, I think now it is time up. Next we have a Sandesh sir's class, it seems, isn't it? He may start 5 minutes early. Okay. Okay, I'll explain because again it takes 5 times. I'll draw and I'll show with the pen actually. Okay.
You'll show this in the next class, ma'am.
Yeah. I'll continue this example as well as I need to continue these 2 slides actually. Okay, so I'll continue from this. Okay, otherwise you just remind me in the next class. Okay?
Yes, ma'am.
We'll
Okay.
discuss this part. Okay, so how it is taking, how we instead of multiplying operations with addition operation, how it is happening, how it reduces. Okay. Okay.
Thank you, ma'am.
Any doubts you can ask in the class itself. Okay. And please at the starting of the class, if it is not audible and if it is not shared, you should tell immediately. Okay. We will take care. But you should also tell. Okay. Sometimes if we are not. Okay. Yes, we'll continue in the next class.